Yesterday, we talked about matched pairs, right? So we had this data, and it was about French teachers going to this camp, right? French teachers going to this camp, and they were immersed in French, and they took a pre-test and a post-test. So when we were done, well, when we started, we always talk the true mean difference. When we get to two samples, the wording of that is going to be different, and we'll talk about how you know it's two sample versus a matched pairs. Because unfortunately, two samples and matched pairs look similar. So, okay. And then we also talked about that anytime you do a matched pairs, your null hypothesis is always there's not going to be any difference between the pre-test and the post-test. And we said that obviously if they're immersed in French, that it should be greater, right? They should actually learn something. And that the problem told us that our alpha level was 0.05. That's where they wanted us to be. I didn't have us write about SRS, normality, or independence, but we did say that in SRS, it's not stated in the problem, so we need to proceed with caution. We know there was 20 teachers, but we don't know how they were selected. Normality, we discussed that it was too small for CLT. We had to draw a box plot because they gave us data. And if you drew it, so I'm just going to show you because I've actually performed this problem. So this is what your box plot would look like. You have an outlier. It's skewed with one outlier. We need to proceed with caution. Okay? It didn't meet CLT. It didn't state in the problem that it followed a normal distribution, and we have an outlier. We need to proceed with caution. Okay? And then independence, remember what I told you? We must assume that the measurements are independent. We must assume that there's more than 20 French teachers, which we can. Okay, so then what we did is we said that it was a one-tailed matched pairs t-test. We wrote down all our information, and we got our test statistic. So right then, the bell is about to ring, right? So we're going to go into our calculators, and we're going to, this was yesterday. So now what we're going to do is in our calculators, we're going to perform a one-sample t-test. A matched pairs, you guys, a matched pairs is always going to be a one-sample t-test. It will never be a z. It will always be a t. Okay? So let's go into your calculators, and you already have the information, right? You already had the stuff? Okay. Okay, so here we go. So we're going to do a stat over to test, and we're going to do a t-test. You guys, that's a one sample. You know it's a one sample. It's not going to tell you, but you know it's a one sample because it just says t-test. And then they gave you data, not stats. You know they gave you data because you entered something into your list. Our mu was 22, right? No. 0. That's right. And yours is in list 1. Okay? I don't know where yours is, but mine is in list 1 because that's what David told me. Okay, and then I want it to be greater than the mu. I want it to be greater than 0. Of course. We're hoping that they learned something, right? And then we're going to hit calculate. Okay. So now with all this information, we're going to write our test statistic. So that T is our test statistic. So our test statistic is 3.8649. Our p-value is 0.0005. We already have our x bar, we already have our s of x, we already had our n. So again, you guys, remember what I told you. That if your p-value has e to a negative number, you have that many zeros less 1, and that's your p-value. Please don't ever write your p-value as 5.2. You will lose a point for that. Okay.
Wait,
go ahead.
Can we write it in scientific notation?
No, they will not take it in scientific notation. No. Why? Because you can round it. Don't write it in scientific notation. Please.
Can we write it in polar coordinates?
Okay. moving right along. Okay, now what are we going to do? So now what should we do? We need to compare our alpha level to our p-value. So it's 0.05 compared to 0.0005. What do we do? What is that?
We reject the null hypothesis.
Okay. Okay. Now, we've done everything that we're supposed to do. The only thing is now we need to write a conclusion. So I'm going to show you the conclusion that I've written. And I probably didn't, you can probably use strong because it is less than 0.01, but I'm going to show you. Okay, you ready? Can you read that? Since the p-value 0.0005 is less than the alpha 0.05, we can reject the null hypothesis in favor of the alternative. We have evidence. We can use strong because our p-value is so small. We have strong evidence, or we have evidence to support the claim that after 4 weeks of immersion in French, in and out of the classroom would improve their French. The normality condition was not verified, therefore we should be careful about generalizing about the population of French teachers. I should also say what? I forgot what.
It was not an SRS.
Yes, the normality condition in the SRS condition was not verified, therefore we should be careful about generalizing about the population of French teachers. See how I went back and I made that connection? You guys, you have to go back and make that connection. If you don't, you'll lose points. Remember, all of this work is 4 points. You don't want to leave without this. Some kids will say strong, and I probably did not use strong in here because I knew that the two conditions were violated. So you don't have to use strong. You can just use evidence. So, and that is a significance test for our matched pairs.